Good morning, Year 10. It's Mr. Sutton here. I'm sorry that we didn't do our live lesson first thing this morning. I wanted to give you a little bit more time to try and sort bits and pieces out, give you a bit of a heads up on it. I want to do a live lesson, a bit of a catch-up, where we'll have a look at some of this work that we've done, maybe have a look at some other bits and pieces of theory stuff. Don't think I'll do drawing live. That might be risking it a bit too much. But I'm going to do that on Wednesday's lesson. So what I'm going to say is that at 10:30, that's 10:30 on Wednesday, this Wednesday, we will have a meeting in Teams so that I can see everybody's faces. And if you can log in for that one, not done a live one yet, so I'm just trying to sort out as well about the little technical details about it all to make sure that you can get in, because there is a little bit of an issue with the group and setting up a meeting at the moment, which is another reason why we decided not to do it this morning. But thanks to those people who have done the previous two tool selections, and as you can see, this is going to be building a little bit on that. I apologise that this is yet again kind of just theory, but there's a certain amount of bits and pieces we need to get through. And if I'm honest with you, the book just, there's so many bits and pieces in here that we want to really get out of the way. And I know that normally you would have been sitting down to do your exam about this time. We would have been thinking of you actually doing your theory exam. I think that's going to be postponed until January. I think you'll get a chance to do it in January and then resit it if you need to at the end of year 11. That's why I think that's what's going to happen now. Lots of debate online about how this is going to be done between teachers. The Welsh Board hasn't really come up with all the details yet because they're concentrating on year 11. But I will keep you posted on that. But that's what I think will happen, which is why I'm really pushing the theory side of things so that if that is the case, you will go back with a decent knowledge of all the bits you will need. So one of the things I will be probably looking at on Wednesday is an exam question where we will go through it ourselves and have a look at bits and pieces. Plus I'll also ask you for a little bit of feedback on what you'd like to hear and see and you need clarification on, because that's something I'm not getting the feedback back from you. Today we are going to be looking at, this is kind of just adding up. Most of the tool section has been done because we've done all those sort of hand tools ones where we did quite a few of the different things with scribes, files, that type of stuff last week. I would like to start the week off and I will only do tools today. I'm not going to do it on Wednesday. As I say, on Friday I'm definitely not going to do it. I just want to look at something which is actually quite a nice one to look at. As far as if you're thinking tools, my favourite ones have got to be welding. And we're looking at joining of metals with this. So there's three different types of welding. And this one here, good old-fashioned soldering. Now, I'm not going to spend too long on soldering because you've had first-hand experience of this one. So you should know really how to solder, and this image just here really points out exactly what you're doing with this. Welding and soldering, it's all about taking two bits of material and joining them with another material, another metal, which usually has a lower melting point, lower temperature than the other materials. Not always the case, certainly not when we get on to the other ones, but in this case with soldering, that is what we are actually doing. So you have your LED here, and it's got these little legs popping through the PCB, or circuit board that's cast, and you've got a soldering iron here. And as you've experienced yourself, what you're doing with the soldering iron is you are heating up the little pad just there, and also the leg itself, that's the solder, the leg itself, so that when the solder goes against it, the solder heats up and melts and actually pulls around those two parts, so connecting them both electrically and mechanically. That's the reason soldering is done. And the great thing about that is you can unsolder bits and pieces as you've experienced, because you can heat that joint back up again and the solder melts. So you've got two pieces of metal, in this case usually something like copper or steel, and then you've got something which is a tin based solder which has a much lower melting point, which means that the soldering iron, which let's face it is just an electrical iron where the tip is heated up, transfers that heat over so that both of those parts become hot enough to melt the solder. And the key thing about that is you are not actually using the soldering iron to melt the solder, you're using the soldering iron to heat up the component parts that you are then adding the solder to. And that just means that it makes a nice, simple, straightforward, and you can see here on the actual PCB, fairly complicated PCB there, it joins those really, really nicely. Now, when we start to move into other areas, we've got oxyacetylene, MIG welding, and also stick welding. Now, all of these are a little bit more complex and a little bit more powerful as well. The first one that I want to have a look at is oxyacetylene. Now, oxyacetylene literally is, when you think of a cutting torch, if you're going into the movies and you're thinking of a cutting torch in the movies, this is the type of thing that you're going to expect to see. It has in it big tanks like this. Two of them. One's oxygen and one's acetylene. It's a mixture of two gases. So similar to what you would have if you went up into science, and also indeed maybe even at home, you have your gas supply, natural gas, and you have your oxygen supply. When they mix, obviously the oxygen's there to help it to actually combust. Oxyacetylene, the oxygen and the acetylene gas in the two cylinders are regulated through this regulator valve just here. And you can see this is the acetylene one. And it allows a certain amount of the acetylene gas, a certain amount of the oxygen gas to come through to the torch. And what it will do is you will see the torch has a nozzle like this. They come together. Let's just bring it along here. And it will be lit like this. So you will get a torch like that, and you can see that he's then taking that particular torch and he's literally lighting it. Now, if I just mute this one so that we haven't got him there, I can hopefully go through this and show you it. I will link to these in here. They are also there, and you can see it produces a very, very, very bright cutting torch. Now, that's a bushy flame, and just like in science where you change the oxygen rating to change the properties of the flame, you do exactly the same with oxyacetylene. But of course, oxyacetylene, and you can see there he's got the green one for the O, meaning oxygen, and he's then just going to increase it. And you can see that very, very hot flame, and you can see it starts to change in colour to that blue. And he's just talking there about the cone. So the end of the cone is where the heat is. Now that's where you have to, and it's really about experience to know exactly where you need to place it to actually melt the metal. There's hotter parts, and also to get the type of flame that you want, because you don't want something that's too long. Here you can see he's got that tip just there, which has now disappeared. That tip of the very blue part is where the gas has just ignited, and it's the hottest part of the flame. So that perfect sort of point just there means that you can do very precise work with oxyacetylene. Downside to oxyacetylene is it's expensive. It also needs quite large, heavy canisters, and this means that it's very difficult to do at home, because these canisters are highly explosive. You need special sort of licenses for it. We do, I think, have the facilities at school to be able to do oxyacetylene welding. It's just that it's very, very rare that you usually do this as a student. Now you can see here what he's doing is he's using that tip of the flame to heat the metal up. And look what happens. He is actually taking those two bits of mild steel and he's using the oxyacetylene flame to actually melt the two together. So there's no extra sort of solder, unlike the soldering iron where we added in something which is a lower temperature. With this particular one, what he's doing is he's melting the actual metal down. So he's fusing it by melting the two parts down. So it's a very particular process. It's used, for example, on fabricating very large sheets of metal, like ships, for example. You would expect that to be joining panels on ships. You would do this. It's often used with thicker grade material as well. You can see here it's quite thick, and you can see how he's joining those up and getting them to be melted. As I've said in the movies, you will see they use the oxyacetylene to cut through the doors. Say in a sci-fi movie, they've got something cutting through the door. This is the type of thing that they would be expecting. Although in that particular instance, it kind of gets mixed up with the next process, which we're going to have a look at, which is stick and MIG, because there's two different ones on that. But I will link to this video. It's quite a nice one. It's a few minutes long, but it gives you, without actually having the process there in front of you, it does give you what it's like, and you can understand the principle of the thing. But remember, it's really about melting those two bits of metal together to fuse them. Now, MIG and stick welding. Stick welding is the one I'm going to start off with because it's the simplest one. This is a little bit different. What we looked at with the oxyacetylene is you've got the two bits of metal and you actually use the oxyacetylene flame to heat those bits of metal up so that they melt together. So they're bonded by actually melting the edges. With both stick and MIG welding, what you're doing is you're introducing a third bit or another bit of material that melts to join the items together. It may be a very similar material to what you're actually doing, and usually is in the case of both stick and MIG, but the way in which they work is very, very different. Both of them use electricity, and a stick welder, let me just see if we can produce this quite a nice sort of, let me see, you've got the stick welder, there we go. You can see that what comes out of the machine is that you've got both a positive and also a negative field or clamp. This one is usually clamped to the base, so the positive is clamped to the work itself. Sometimes the actual material, so say if you were doing it on a car, you might find a spot on the car where it's got a good connection so the electricity can flow, and it has these clamp parts that clamp down onto the work. The minus one is where the stick is. So what actually happens is that you are completing a circuit. So you've got this clamp going onto your metal, you have your stick coming in, and when the stick touches the metal, that completes the circuit. So you've got somewhere at the back here, he will have the clamp onto this one, and then when he actually puts there, it's completing the circuit. Now when it completes the circuit, the electricity flows at very, very high current, and what happens is it melts the end of the stick. It builds up so much resistance, the electricity flowing through it, that it actually produces a melting experience, and it heats up the metal hot enough so that it melts it down. And you can see in this one it going along. Let me just see if we can again pause it, mute it, and I'll show you what it does. And this, then you take the stick and you move it along, and you can see it on here. You get a lot of sparks and a lot of spatter and stuff like that. Notice as well there's kind of like a gaseous cloud coming off this. Now that's quite important, because if we go back and we have a look at the stick, it doesn't look like it's just metal. And in fact it's not. It's an electrode which is made out of some of the material that's going to melt, and it's coated in a kind of ceramic powdery stuff on the outside. Now when the electricity flows through it and it heats up the inside of that stick, especially at the tip, what happens is that that particular powder that's around the outside expands and actually combusts and produces what we call a shroud. This is an area around where the work is being welded. The oxygen is pushed away, because oxygen is really the enemy of any welding, because with steel, as I'm sure you know, if you add oxygen to it, it rusts. And it causes what we call porosity, which is where there's loads of little bits and bubbles where it's going to make a very weak joint. There's a puddle of molten metal here that's forming along this point. This shroud of gas, this inert gas that's coming off this stick here, is pushing the oxygen away so that this molten metal doesn't actually corrode. It doesn't join with the oxygen, so you're not going to get that rust forming. You're not going to get all that porosity and nastiness. You're just going to get a very nice, clean weld. And you can see here that's exactly what's happened. It's produced a nice clean weld where the metal has melted, and it's melted in such a way that it's produced a nice, clean, shiny surface. Notice he's knocking away the outside. This is like the brittle surface of the actual material that has kind of reacted slightly with the outside of the stick, but you can see this is nice and shiny, and that's because that shroud, that outside of the stick, has pushed away all of those kind of impurities, the oxygen, and stop it from reacting. So stick welding, used a lot. Very, very good for thick pieces of metal. You can see here that this is a good few millimeters in thickness and is really, really good for that type of thing. Finally, we have my personal favourite, and the favourite of just about any sort of novice sort of car mechanic, and that is MIG welding. Now, MIG welding works on a similar sort of principle to the stick welding, in that you have a kind of positive and a negative, and that you have electricity flowing through, and in this case not a stick but wire, what you will find is that you have this. You have your metal here, you have your gun, a little switch there that activates a feed. What it does is it pushes a coil of metal through the end here, and that feeds that metal into here, and of course it touches, and what that happens then is just like in the stick welding, it actually ignites, it heats up because of the voltage and the current going through it, and melts. The wire is very, very pure. It has a little bit of usually copper on the outside, but it is actually very, very pure. The shroud, the gas that is stopping the oxygen from reacting with the metal, is actually created from a gas canister. So it's a bit similar to the oxyacetylene in that MIG welding needs a supply of gas, whereas stick welding doesn't. It's all in the stick, which is one of the reasons why stick welding is very good for outside and is often a good sort of portable thing to do. You can literally pick it up, take it. You don't need these big cylinders. Whereas MIG welding does need a cylinder of some type, because what it does is this area here where it's melting down needs to be an inert gas, usually one of the noble gases. And I'm sure you know, if you're chemistry, what the noble gases are. The unreactive noble gases in the periodic table. So things like argon is a particular one that's used quite a lot. And that means that it stops the oxygen reacting at this point. Now, you can see what goes on with this, and I'll just again mute it and play it. And what tends to happen is that the wire comes through and it melts in that point. You can see this area of the shroud, as it's called, is where the gas pushes away all the oxygen. So here we have that cloud of the gas, and this is the coil of wire inside the machine. So the wire electrode is pushed out of the actual gun itself, out of the nozzle, out of the tip of the MIG welder. These can be replaced because they do kind of burn out eventually. And that's actually what melts down. So the wire is what's melted down. And you'll also see the nozzle itself, there you go, produces this shielding gas or shroud around the outside. And that just comes from a standard regulator, sometimes inside the machine, sometimes separately. Now, there is a little bit of changes that are a bit more technical, and really you don't need to know about this, but the amount of voltage, the current, and also how fast the wire goes through the machine are all variables that can change with MIG welding, depending on how thick the material is that you're actually welding, the conditions, and also the material itself. And it depends, because sometimes you increase the amount of voltage, increase the current, increase the wire speed, so that you get a larger amount of puddle, if you like. But it is a very sort of technical thing, and you have to understand how it works. Here it just basically talks about how they use the positive and negative. With this one, with MIG welding, it is the positive that's in the gun rather than the negative, which is usually with the stick welding. And there you can see the clamp that goes back to the machine, just as I mentioned with the stick welding. So that is clamped onto it and produces the return path for the electrical flow. It's as simple as that. So those are the kind of three main joining points. Fourth one with the soldering. Soldering is a little bit different. What I'd like you to do is, just as you've done before, a little bit of an image, bit of an explanation and notes on this. Have a watch of these videos. There's just 3 of them. You can skip forward quite a few of them. I'll allow you to get to the most important bits. You just need to know about how it works, bit of a diagram, and you're good to go. And I will see you on Wednesday. What I'll do is I'll pick some of those and we'll have a discussion on Wednesday about particularly good ones that have been done. We'll talk about the processes that we've mentioned as well, and we'll have a little bit of a look at that question as well. All right then, everyone, I will see you on Wednesday. Thanks again, and take care of yourselves. Hopefully you'll have a nice Monday, and I'll see you all on Wednesday. Take care.